So this is interpreting linear functions. I'm on page M2-25. We're not going to do this part up here. I feel like we've been doing this a lot, knowing if something's linear or not linear. So we're just going to start on this problem right here. So it says Dylan sells pretzels at festivals on weekends. The table shown is a record of past sales. So notice he sold 15 pretzels and made $37.50. One weekend he sold 42 and made 105. And so you can look at that to see how much money he has made. Instead of doing what they asked, we're going to use the process column to find the equation. I feel like it's been a little while since we've done that. And then how much money would Dylan earn if he sold 75 pretzels, and it says use the equation. So there's not enough room right here to do the process column. So I did start on a notes page. Notice I put number of pretzels sold, process, and then amount earned. So you can pause the video to write that down, and then I'm going to start working on that. So I'm going to slide that up. So if we look at this, it says number of pretzels. The first one is 15, then 42, 58, 29. I am particular about how I set things up, so I want to set them up in order. So I'm going to do the 15 first because that's the lowest number. So 15 was 37.5. Then the next highest number, 15, 42, 58, the next number would be 29. So I'm going to do 29. And 29, when they sold 29 pretzels, they made 72.5. And then we have 42 would be next. So 42, they made 105. Then 58 would be 145. So you don't have to do that. I just feel like it's easier whenever we're finding out the cost per pretzel. I think it's easier if the numbers go in order. Okay, so now in order to do the process, remember we're going to figure out how much it's changing by. So if you look at that, we're going to start with amount earned. So we want to know how much did they earn for how many pretzels, and then we can figure out how much they earned per pretzel. So you're going to take the second number, so 72.5, and subtract the first, minus 37.5. And so that changed by 35. Okay, then we're going to do 15 to 29. So I'm going to do 29 minus 15 is 14. We're going to do 72.5 to 105. So 105 minus 72.5 is 32.5. 145 minus 105. I'm just going to go ahead and finish out that side. Okay, then let's do this side. 29 to 42. So 42 minus 29 is 13. 58 minus 42 is 16. So if you were to just look at that right off the bat, initially you would think that they are not changing by the constant amount, meaning it would not be linear. But if you actually divide 35 by 14 and you divide all of these, you're going to see something. So I'm going to go ahead and do that down here. So remember, it's cost per pretzel, or 35 over 14, and we're going to see what that gets. So again, I'm just going to use my phone calculator. So 35 divided by 14 is 2.5. Okay, let's do the next one. 32.5 divided by 13. 32.5 divided by 13 is also 2.5. And then 40 divided by 16. 40 divided by 16 is also 2.5. So if you look at those, they're actually all changing by the same amount. So when we're doing our process column, you take that number right there, so the 2.5, so 2.5, and then you're going to multiply it by however much is sold. So you're going to take the rate and multiply it by how many are sold. So in this case it's 15. And then we're going to see if we have to add anything on. And that's how we use the process column. So you're going to do 2.5 times 15. And you get 37.5. So since that's exactly the same, there's no fee, there's nothing extra that they're charging. So it's just 250 times 15. Now, this 250 we've said was the slope or the rate of change. Now, this whole topic right here, or this whole lesson, is called Interpreting Linear Functions. So what that means is you're supposed to take this 2.5 and say what it means in the context of the problem. So you'll hear in math the word context. That's just the meaning. So what's the meaning of that 250 or $2.5? So that meaning is it's $2.50 per pretzel. And you know, because the 35 was the cost, and it was $35 change for 14 pretzels, or it was $32.50 for 13 pretzels. So that's how much the change was. So that's what it means by the context. So anytime you see something talking about context, it's just what is the meaning of that number. So the 250 times 15 gives you this. So let's check the next one. 2.5. So 2.5 times 29 pretzels should be $72.50. So that's correct. So let's check the next one. 2.5 times 42. So 2.5 times 42 should give you $105. That's how much he would make. And then the last one, 2.5 times 58. So 2.5 times 58 is 145. Okay, so that means we don't have to add anything at the end. So let's call this P for pretzels. So we're going to put the letter P here. So then for any number of pretzels, so 2.5 times, it doesn't matter how many pretzels we buy, we can use the letter P to represent any number, is going to give us, let's say that that's going to, we'll use the letter A for amount. So we'll give us A, the amount earned. So our equation that we're going to write in our book, or we can write it at the bottom, is going to be A equals 250p. It's $2.50 for every single pretzel. Alright, now let's go to the next one. How much money would Dylan earn if he sold 75 pretzels? So what you need to think about is this is P, this is A. So in that equation, would the 75 go in for the P or would it go in for the A? Well, the 75 is the number of pretzels, so it would go in for P. So for your equation, you would do A equals 2.5 times 75. So 2.5 times 75 gives us $187.50. That is how much money he would earn, or that's the A that the amount earned if he sold 75 pretzels. Okay, let's go to the next one. So number 3, Delaney and her friends recently went to the community fair. They had to pay an entrance fee and then purchase one ticket for each ride. Dakota is going to the fair tomorrow and wants to know the cost. So again, we're going to write the equation. So let's see if we can, I'm going to quickly transfer this one over. So number of tickets, and then process, amount spent. So again, it doesn't tell you what letters to use, so you can create your own. Just make sure you identify them. So T is for tickets. A is amount, and it can be whatever letter you want, X, Y, it doesn't really matter. It's just whatever you choose. So 2, 4, 6, 11. Those ones went in order. 750, 9, 10.5, and 14.25. Okay, so let's again do the same step. So I'm going to subtract those. So 9 minus 7.5 is 1.5. 10.5 minus 9 is 1.5. 14.25 minus 10.5 is 3.75. 2 to 4, so 4 minus 2, of course, is 2. 6, 4 plus 2 is 6. Then let's do 11 minus 6 is 5. Okay, let's set up all of our rates. So 1.5 over 2, 1.5 over 2. Again, it's amount per ticket is what we're going to end up trying to find. Then it's 3.75 over 5. So let's do that. So 1.5 divided by 2 is 0.75. 0.75 because those are the same numbers. 3.75 divided by 5. 0.75 again. So notice this rate is the same. So again, in context of this problem, what does that mean? That means that it is 75 cents per ticket. Because the 1.50 was the amount, this was the number of tickets. Sorry. So then we're going to do 0.75 times 2. Remember that 2 comes from how many tickets were sold in this part of the problem. So we're going to do 0.75 times 2. That gets us 150. Now, notice, and I'm going to write this in pencil below it, this part right here, actually I'm going to write it above because there's not enough room below. So this part right here is 150, but we need to get to 750. So 150 plus what gives you 750? So you can take 7.5 and subtract 1.5, and you know you have to add 6. Or if you could just see that, you are awesome. And so we know we have to, in this problem, or this row, have to add 6. Let's make sure that that's the same each time. So we're going to do 0.75. The next row would be times 4, because there were 4 tickets bought. So 0.75 times 4 is 3. What is 3 plus what gives you 9? Well, 3 plus 6 gives you 9. So that, again, would add 6. So then we're going to do 0.75 times 6. So 0.75 times 6 is 450, plus 6 is 1050. So it does work each time. So this last one, let's write the whole thing out. 0.75 times 11 plus 6. Let's see if that works. So 0.75 times 11 plus 6 is 14.25, which is correct. So then now let's do it for any number of tickets. So the 0.75 still stays the same. Notice each time what was changing in our equation. It was 2, 4, 6, 11. 2, 4, 6, 11. So then, of course, you're going to multiply by the number of tickets. That 11 came from the number of tickets, so on and so forth. Plus 6 would give you the A amount. So our equation would be A equals, I'm just going to write the whole thing in one color, sorry, 0.75 T plus 6. So think back to the original problem, what they were talking about, and so they asked what was the cost per ride, or cost of each ride ticket, and then what was the entry fee. So looking at this problem now, how much did they have to pay to get in? So if they rode two rides, or they needed 2 ride tickets, they paid $7.50. Well, that's because it was $7.75 per ticket, and then they had to pay $6 to get in. This one, it was $0.75 for 4 tickets plus the $6 entry fee. So that 6 would be the entry fee. And then, so this next one says if Dakota has $20 to spend. So what I'm going to do, I'm going to use this other calculator just because it will go quicker. So I'm going to do 0.75 times, well, if you look at 11, it was $14. Well, let's think about if they want to get to $20. So let's try maybe 15, but remember to add the $6 on, $17.50. Well, let's try another one, 0.75 times, it looks like I need to jump up a little bit more, plus 6, that's 19. Let's try another one, times 19 plus 6. So that's $20.25. So we actually don't have enough for that. We only have a $20 bill. They're not going to let you be short. So the answer here would just be 19. Now, in some cases, and I know this video is getting long and I apologize, but I want to make sure to finish this problem out. So in some cases, you don't want to just keep trying random numbers. So I'm going to take our equation, A equals 0.75 times tickets plus 6. Now, since in this case the 20 was how much we had to spend, I'm going to rewrite our equation. 20 equals 0.75t plus 6. Now, we know if we have $20 and we want to know how many tickets we can buy, what you're actually going to do is you're going to take 20 and you're going to subtract the $6 entry fee. So it would do 20 minus 6, which is 14. So they only have $14 left to spend on tickets. So they have $14 left. Well, how much did it cost per ticket? Think back to what we were doing on this page before in the process. It was 75 cents a ticket. So we're going to divide by 75 cents. So 14 divided by 75 cents means they can do 18.66667, which if we go back up, I wrote 19 as our answer, and it's actually 18 because remember when we put 19 in for tickets, we only had enough for 18 tickets. It was just under the $19, or the $20. So we only have 18. So if you look here, it doesn't matter that this rounds up to 19. We only have enough for 18 tickets. Hopefully that makes sense. Okay, sorry that video was so long. There was just a review because we hadn't done process in a while.